Yeah, welcome to Electro-Hive Research Institute of Technology. My name is Yakub Mohammed. I'll be taking us through the basic introduction to STM32. I did say that we require two basic software, the STM Prog 32 and the Atolic Studio. So I will just start the Atolic Studio. While we wait for it to come up, let's go through our basic hardware. Remember I told us that we need any board, whether it's a 103 or 407. We have different versions that are available that you can buy. This is the mini board I had before. This is a 103 version. This is still 103. I have the 103. I've wired the 103 with my programmer. It's actually an XT link. Then I've added a diode to port A0. So today we'll be looking at how we can actually program an LED, more like a LED blinker. Let me take this one off. Okay, so like I said, I have the LED wired to port A. It's wired in the it's wired in such a way that the anode is connected to 5-volt supply and the cathode is connected via a 220 ohm resistor to port A0. Okay, let me just put this aside. Okay, this is the software, is up now. Not too sure if it's clear. Alright, so the first thing you want to do is review your software. You just look at all the positive navigation. If you look at there are three basic windows: the window on your left, let's say four, the window on your left, the middle one, the one on your right, and of course at the bottom one. I think the Project Explorer, it's where all your projects are safe. For my own, I have 5 projects already, so that's why I have information on this Project Explorer view. In your own case, you're starting it for the first time. This will be what? It should be blank. So let's just say it's blank. Alright, so the first thing you want to do is start a new project. Like I said, we are using the STM32F103. So whatever project we're building for today will be based on 103. But you can still apply the same for 407. Why you have a 407 board or the 103? The same is still the same procedure anyway. So the first thing you want to do in creating a new project is first you go to File, go to New, File, New. We want to create a new project. You can either create a C++ project, a C project, or a C/C++ project. I would prefer to take the C/C++ project. Hit the Enter key. Okay. So the next is I want to create a C++. I had two options, whether it's a C or a C++. Like I said, let's create a C++ project. Take next. Okay, we need to specify the project name, a name for the project. Let's say LED blinker. LED blinker. So just type LED blinker. Alright, that I haven't done. For the project type, we have empty project, we have the CMSI project, CC+ project, we have the PCC project, we have the embedded C project. So we are trying to create an embedded C project, so I'll just take the embedded C project. The tool chain is AMP2. I'll take next. Okay, the select hardware settings. At this point, you are required to select the hardware you want to use. From the device drop down, you can actually see the 32F0, F1, F2, F3, F4, as the case may be. For this project, we say we want to build for 103, so we just go to the F4 version, or the F1 version. There are two options. If I have a board like the Nucleo board, the Discovery block board, as the case may be, I can decide to select based on board. But for now, let's just select based on MCU. I'll take MCU. we know that our chip is actually 103. So I'll look for 103. I have there are different varieties of 103 here, so you just need to specify the one you have. In my own case, I'm sure I have the arrow B. I'm not sure. Let's see if I can see that on the board. It's not too clear. Let's see. I think that should be C8 or CB. Let's say it's CB or C8. I'm not sure. Okay, there is no CB. There is no C8. Okay, I'll just pause the video and be sure, so I can select the actual chip I have. Okay, I think it's C8, so I'll just take C8. 103 C8. In your own case, you need to select the chip you're actually using. Although they are almost the same, but it's good to select the specific chip you're using. Next, I want to go to the next page. I'll leave the other things at default settings. Next, I'll take next. Leave everything as default setting. I'll take next. Okay, it's asking for my debugger. Let's say because I'm using the XT link, I'll take XT link, but it doesn't really matter whether it's I'm using the Sega J link or XT link, but let's just take XT link. Then go to next page. Okay, okay, at this point I can finish. Take the finish button. Okay, let's allow it to load. Alright, the project has been created. So we'll go to our project explorer. We'll just minimize. We'll still see all our projects are there and it has added to our project explorer. You can see a small C on top, meaning that project is active. Every other project is closed. If I want to close the project, I'll just right click and take a close project. If I want to open the project, I'll take right click and say okay, sorry, it wasn't close. Right click and close project. Okay, let's see. To open the project, you double click it. Coming. Okay, let's just cancel this, sorry. So as you can see, the C is showing that the hello project is actually opened. Every project are actually closed. I can open more than one by just right clicking it, but I like to always ensure that it's only one project that is open, so you don't mistakenly go and type in the wrong code. So I'll just go back to LED blink and right click it. Okay, let's just wait. Okay, the C means that it's open. Let's close this now. Close project. Close project. Okay, the hello is now closed. The LED blinker is open, so I'll just click on this arrow. These are files that are associated to it. One good thing about Atomic Studio, that each time you create a project, it creates all the necessary library for you to use. Atomic Studio came with libraries that you can use, but I'll show you how you can actually go through them. It does not have enough documentation, but going through the files, you'll be able to understand how each library works and how you can actually use them. So the first thing I want to do is click on the RC, which more like the source. Just double click it. It has a drop down. These are all the files that are associated to this project. It has the main .ccc. It has the startup. You can see the main .cpp. It has the startup STM32 MDS. It has the configuration file. It has the interrupt files. This is the .c and this is the header file. And it has the system startup and it has the printfc. For now, we'll only be interested in just the main, the main file. So I'll just click on the main file. It comes here. So this is the main file. Now, one thing I don't like about Atomic Studio, that although we have created a new project that added some libraries for us, that added some code for us that we don't really need. This is one thing I really don't like about this studio. But don't take that away. Atollic Studio is one of my best preferred studio when it comes to programming ARM. Atollic Studio was actually owned by a third party until STM acquired it some few years ago and made it a free compiler. Before now, you have to buy it. You have to have a license to be able to use the Atollic Studio. But when STM came and acquired a part of it, they now had to create the STM version of that Atollic Studio, and that's why you will now see that the name is given as Atollic True Studio for STM. So what that means that there's an Atollic True Studio that can be used to compile other ARM controllers. So the next thing you want to do is to empty this page, empty this file. So what I like to do is I'll just copy everything and delete. And delete. I'll just delete everything and create a fresh and have a fresh new page. All of those things we had, we don't need them. So okay, sorry, let's take Ctrl Z and take them back. Ctrl Z, sorry. Okay, I was not going to delete everything anyhow. Let's just delete those parts that we really don't need. I will delete this to my main. I'll leave it at this point. Let's take it up a bit. Okay, I don't need all of this. I'll empty the main function. Take it up to this. I don't need this. I'll delete everything here. I don't need this. Okay. So if you remove everything you have, this is what this is the only thing you'll be seeing on your screen. So like I said, the page he created for us, we really don't need all of those. So what do? We deleted them. So this is what you have. And what I like to do is at this point, you don't want to compile to be sure that your main program or function is still intact. So I'll just go to project, and I like to use, you can actually build all the project. If you have other files, you can build the project as the case may be. You can rebuild it, you can clean, you can do other settings, but I like to just rebuild. I like to use the function rebuild. So while it's rebuilding, you see the task bar running to show that it's rebuilding. If everything is okay, we will see that there won't be any errors. But once there's an error, it means that we have deleted what we are not supposed to do. But like I said, each time you create a new file, it creates so many functions, so many code that we don't need. So as you can see, it has finished running, and there are no errors. So the next thing is to add some functions to it. And first is, for every IC you use, you need to know what the crystal is, so you can enable the crystal, because there is no MCU that will run without a crystal oscillator. So the next thing we want to do is to first decide what crystal do we have on board. In my own case, I have an 8 megahertz. You can't really see it here. It's an 8 megahertz. So I'll need to specify that I'm using an 8 megahertz. If you're using 25, you need to specify it. Okay, like I said, you need to specify the crystal you're using. In my own case, I'm actually using an 8 megahertz. I like to do copy and paste, so I've already copied that. I'll just paste it here. Okay, so this is what I pasted. Is hash define HSC value. It means that I'm going to be using a HSC value of 8 megahertz. That's because on my hardware I have that as my crystal oscillator. HSC means high speed external crystal. So it means that if I'm having a 25 megahertz, I'll change the 8 million to 25 million. So at this point, I've told my compiler that the hardware I'm building for, the crystal oscillator will be, the MC will be running at the crystal oscillator for 8 megahertz. So if your own case, if you're using a board that is different from mine, you need to find out what the crystal oscillator is, then change this 8 megahertz to whatever crystal you're using. The next thing I want to do is to Once I've done that, I'm sure my crystal oscillator will run at that speed. The next thing I want to do is to now enable, unlike other MCUs, once you don't even need to specify your crystal oscillator in software, you just run your hardware and do your configuration. But STM requires you to tell Atomic Studio for STM requires you to specify the crystal you're using. The next is to actually define or probably enable the clock for each hardware. Unlike other MCUs like the AVR, if you're coming from the AVR background or PIC background, once you have enabled your crystal, you're good to go. But for ARM, you need to activate or probably enable each clock. Each hardware has its own separate clock. For instance, your port A is a hardware internal to your MCU. It has its own crystal. It runs on its own speed. If you're using UART has its own crystal. If you're using XPI, I2C, all of them have their own internal clock. So you need to enable this clock. You need to tell the compiler that you need to activate this clock. Otherwise, you will just write your program and your program will not be running. So let's activate that. Okay, I just copied that code again. Like I said, I like to do copy and paste. It's easy for me to just copy it and paste it rather than just type, because I'm using the same cam. I will have to hold the camera while I'm typing, so it's not too flexible. So most of the time I'll be doing copy and paste. So I just pasted the code, the line of code that actually activates or probably enable the clock. As you can see, it's actually RCC APB2 peripheral clock command for all port enabled. This is saying that I want to enable all my clock ports, all my port clocks. So it means that port A to whatever port it has, the clock are enabled. Now, if you're wondering how I got this function, sorry, there's something I actually skipped that I didn't tell us. I did say that STM created library for everything, and that's one good thing about Atomic Studio. Everything you're doing, there's a library for it. It has library for clock configuration. It has library for toggling of ports. It has library for putting on your port and on. So that's what makes it very, very flexible to use. So before I go further, let's even look at some of these libraries that are available. First, we'll look at the RCC library and see what are actually available for us to use. So one way to do that is to click this down. You see that there's an include. There are libraries. I'll take my libraries. There are CMS. There's standard library. Okay, sorry. So I'll just I went to the LED link itself, took me to library. Let me go back. Okay, I'll take library. I'll take this. There is an include and there are sources. These are the .h and these are the .c. So let's look at the .c files. Take this a bit from here. Okay. So these are all the available libraries that we can use. You see that it has an ADC library. That's the backup power library. That's the CAN. That's the CAC. That's the CRC. That's the DAC. Debug. That's the DMA. The interrupt. The external interrupt. The flash. The FFC. The GPIO. I2C. These are all the available libraries. Now we're looking at the library for the clock. We'll just come here and click this to open the file for us. Okay, the file is open. Let's look at. These are all definitions that we can use on the library as far as clock is concerned. I'm more concerned about the function itself. So let's scroll down to where the functions are. Okay. Okay, these are all the libraries you can use. I'm more concerned about the peripheral clock command. Let's see it somewhere here. APB2 peripheral reset command. This is the library here. Okay, this is where it is. This is the APB2 clock command. It's here. The parameter is that you can actually send the variable, which is an unsigned32 variable, to it and its function state, whether it's an enable or disable as the case may be. So let's look at the source file itself. This source file, go to the C, RCC. Okay. We're looking at the peripheral clock command. somewhere. Okay, this is the AHP peripheral clock command. We're looking at APB2. We're looking for APB2. Okay, APB2 peripheral clock commands. So let's look at the description. So if you're actually looking at it the way it is, it's a little bit not clear here. Okay, you see that I can actually enable or disable the high-speed APB2 clock command. The APB clock command specifies the APB peripheral to get its clock. So we need to know what peripheral the APB2 clock command can actually be used to activate or deactivate. For instance, if you go further, you see that this parameter can be any combination of the following values: the alternative function, that's the AF, the GPIO-C, GPIO-A, GPIO-B, C, GPIO-D, up to the timer 1. So it means that if I call this function and pass any of these parameters to it, and the function state can either be enabled or disabled. Once I do that, it means that the clock has been enabled for that particular hardware. So as you can see in our main code, what we have is the what? All port clock. So it means that all ports, their clock will be what? Enabled. Like I said, STM actually created so many libraries that makes it flexible. But sometimes we don't get that flexibility. But let's just keep looking at what can be achieved with it. So that being done, it means that our port has been enabled, the port clock has been enabled, we have specified our crystal oscillator, we have enabled the clock for all ports. The next is to actually define the port we want to use. From our hardware, I've actually tied the LED to PB port B0. So it means that we're going to be using port B0. If you have programmed other platform like Arduino, you don't even need to specify the pin position. If you've been using AVR, you know that before you can use any port, you need to specify, you need to initialize that port, whether in an input port and output port. The same thing goes to PIC. The same thing goes to the XTM itself. So if you're going to be programming a port, you must first initialize that port. And to do that initialization, like I said, the Atomic Studio gave us so many libraries that we can use. So it means that if we want to talk to port, or probably want to configure or write to port, we need to look at the GPIO libraries. So let's close these two libraries and look and open the GPIO library. So just close this and this. All right. So the GPIO library will be somewhere here. GPIO-C, that's the C source file. I like to look at the header file. It's easy to navigate through the header file. Once you see what you want, then you can now look at the C file itself. Let's look at the GPIO header file. Okay, going by it, we just see all. I like to just go to the function directly and see what functions are available for us. These are all the functions that I can use in this library. I can actually deinitialize a port. I can set the alternative function of the port. I can initialize the port. I can set the structure. I can use structure to initialize it. I can read an input data bit. I can read an input data itself, more like you're reading the entire port. I can read a particular pin. I can read the output data bit. All of these are the functions that I can actually do on the STM. So like I said, we need to initialize it, and then we now need to write to it. So first, let's initialize. Like I said, I like to do copy and paste, so I'll just do a copy and paste, then I'll explain what I have pasted. Okay, I just pasted the initialization code. So the first is the data. This is just trying to say that, okay, I'm going to have a kind of variable called GPIO initialization data type called my port. Then my port is going to have a structure. It's going to have a member called the GPIO pin. It has GPIO speed, GPIO mode. All of this, if you look at the GPIO header file, we'll see what they are. GPIO pin 0 is saying that this is the first bit on that GPIO. This is specifying the speed. if you look at the datasheet will tell you what are the available speed for every port. Like unlike AVR, the AVR is expected to run at the same speed the clock is running, the toggling of the pin itself, but it's unlike the STM. Even though we say we are run at 8 MHz, that does not necessarily mean that the GPIO pin is actually run on 8 MHz. Something I even forgot to tell us. The default speed that the compiler will set for you is the PLL. By default, it enables the internal PLL. I remember I said we added a crystal for 8 MHz. That does not mean that the clock is actually running on 8 MHz. It's actually running on 72 MHz. That's for the case of the 103. The 103 has a PLL that runs on 72 MHz. Okay, like I said, for AVR or PIC, once you want to use the port pin, you just configure. You don't even need to set the speed of the port, but STM requires you to set the speed, what speed you want it to run at. Like I said, if you look at the datasheet will tell you different speeds that are available for different port pins. So as you can see, we are going to be running our port pin at 50 MHz. Then the mode is going to be an output mode, which is a push-pull output mode. Like I said, all of this information you can find in our GPIO header or GPIO.c file. So these lines of code will automatically initialize the port pin to be an output pin. The next, because it's a LED blinker, we want to actually bring the port pin on and put it off. So the next thing I want to do is just to, I like to do copy and paste. Don't mind me, I'll just copy the required code that would run the on and off. So we could just test it. So I'll pause for now. Okay, I just pasted the code. Okay, as you can see, it's actually GPIO write bit and GPIO write bit for bit set and bit reset. Okay, I'll just change this to bit reset. I was trying to reset caps lock. Reset. Okay, it's actually bit set and bit reset. With these two lines of code, the port is expected to come up and go off. But we know that for this IC, it's actually run at 72 MHz. At 72 MHz means that with this code, the LED might just stay on or might even stay off because it's so fast. We need to put delay so that we can actually see it. We can adjust it to real time, because in reality, the speed at which the MCU run, we say the 72 MHz. That's because it's running on internal PLL. With internal PLL, it means that the chip will be running very, very fast. So to put a software delay, we could just create a software delay. So what I'll do, I'll just copy the code again and just paste. Something I'll just do nothing to let's say I'll just copy and paste it. Let me pause. Okay, I just copied and pasted the software delay. Okay, so what I have here, it's just a counter that will count from 0 to 16,800. I'll have another inner loop that will count 100 times, so more like 16,800 times 100. That's just the delay. But this kind of delay is not accurate, because these are counting of variables and delaying. We are not sure what time it takes to execute one instruction, or probably because these are C code. If it was an assembly code, we're able to calculate the time it takes to execute one instruction. In C, it's difficult to do that, except you are a very, very good programmer. You can easily tell that this software delay can take this time. But because we are just testing, we just need the LED to blink and come up and go off at a different time interval. We are not too sure, we are not too specific about the timing. But if you need a specific timing delay, or probably a timer that is precise, then this is not the best option. For testing purposes, we can use this to test. So the next is to, like you have noticed, the same delay I have here, I've copied and I have pasted it here as well, so that I have the same delay in between. Now this code is expected to on and go off at the same time.